Good afternoon, this is Jay, and this is a review of the Zenbot 4896 CNC router. So I got this router for an application of building tables. They're specific purpose tables, but fundamentally they're still tables. And I just want to talk about a couple of things about the router. This router has a really good price point. So it starts at around 5,000. And for this price point, I was unable to find really anything else that could do 4x8 sheets within like a $5,000 within a $5,000 price range. So that's was one of the major deciding factors for me to purchase this machine. So the other thing you need to be aware of is that you get what you pay for. The next step up from something like this, not necessarily from Zenbot, but just in general, is going to be likely in the $10,000 to $15,000 region. So I would consider that significantly more expensive, but you're probably also going to get a little bit more there as well. Another limiting factor that I have is just the amount of power that I have available in order to drive the machine. So this is running off of 215 volt circuits. One of the circuits drives the spindle, which is the Hitachi MV12. It's a little dusty, but Hitachi MV12, and then the other circuit is driving the computer, and then all the servos. So it does work. This is a spoil board that I made yesterday to get everything connected. I need to build more spoil boards, but that's just part of my modular system. The table itself has a large array of holes built on them, so you can sort of connect whatever you need to connect in whatever way you need to connect it. And it cuts. And there's a couple of videos I have on my channel of it cutting. And generally, I think for the $5,000 price point, this is a pretty good machine. It runs Mach 3. So I'll come over here. I didn't bother to turn any of this on, so let's turn it on. So it runs Mach 3. So this is just an old computer I have, Core 2 Duo, and then this is the driver, and then screen and whatnot. Side note, this uses Mach 3, and Mach 3 only runs on 32-bit Windows, and it doesn't run on Windows 10 anymore because Windows 10 made an update. So you need to use, as of today, 32-bit Windows 7. And so I had to go purchase a copy of 32-bit Windows 7 in order to get this to run right. If you don't do that, if you use 64-bit, the parallel port does not work, and then you can't drive the machine. So we'll just look at the wiring here on the back real quick. So parallel port goes into the driver, and then these are the axes. So this is technically a 4-axis machine, and the reason why it's a 4-axis machine is because the X gantry has a motor on each side. So there's no extra room in here to pop in a rotational 4th axis or anything like that, because the other 4th axis, which is the quote-unquote A axis, is over there. So that's X and that's A. So you're not going to be able to add anything or add any put a rotary table or anything on this unless you change out this driver to something else that can do other things. That being said, for this sort of standard wood application, it's not really commonplace to do things like that. That's more of a metal thing, less of a wood thing. So if you're buying a 4x8 router to do sheets, this will do it. So so there's Mach 3. There's a whole bunch of tutorials on how to use Mach 3, and Mach 3, I've come to really appreciate Mach 3 as a controller. It would be not too difficult to also, use your own controller like Linux CNC or something like that. But I just wanted to get cutting, so I decided to, buy all the Mach 3 stuff and, get the drivers and all that other stuff, just because I wanted to sort of get cutting and not have to worry about putting everything together. So, where does this fit? This is and I mean this in the best possible way, this is the best worst machine that you can possibly buy. So out of the machines that are in its price point that do what it does, it's, as far as I'm aware, it's kind of your only choice. So you're going to get $5,000 worth of performance instead of 10,000 or 20,000 or however many $1,000 worth of performance, right? So you just have to keep that in mind. If you're going to use this in a heavy duty production environment, it's probably not the right choice for you. I would consider this a hobby plus class machine. So it's not like a professional class or like an industrial class of machine. It's people who, have hobbies that are really looking to take those hobbies to the next level, but they're not necessarily at formal industrial levels of production. So I think that's fine. And I think at its price point, it serves that purpose quite well. That being said, there's a couple of gripes that I have, but most of those gripes would most likely increase the cost. But there's still a couple things that could be, I think, improved. One of the things that could be improved are the directions for assembly. So you get a little packet with no pictures, just text of, assemble this into this, and then assemble that into that, and assemble this into this. And that was very confusing, to say the least, especially because I had packages that didn't always arrive didn't arrive altogether or in the correct sequence. So I ended up like opening up my packages and then starting to try to assemble it. And I'm like, am I missing parts? Am I not missing parts? Do I have everything? Do I not have everything? It was just kind of confusing. Now, thankfully, most of the way this thing goes together is pretty intuitive for the most part. There are a couple places where you can get snagged and you might have to like undo a little bit of your work and then redo a little bit of your work, which happened to me. And that's because I stopped using the directions because the directions weren't really that good. But after assembling it completely, I went back and reread the directions, and then the directions made sense. So yeah, but if there were some pictures or like a video of the assembly or something like that, I think that would really help the assembly process. I contemplated making one, but I really just needed to get my machine together and start cutting. Let's talk about some of the more mechanical aspects of the machine. So this is all made out of, these are all heavy pieces of plastic. It feels maybe like some kind of like nylon or some nylon based plastic. It's reasonably rigid. It's not ridiculously rigid, but it's reasonably rigid. And this is part of where that $5,000 price point comes in. If these were aluminum, everything would be a lot more rigid, but then the price would also increase a lot. In terms of like the quality of these actual parts, I would give the parts themselves a B out of a regular grading scale. Some of the parts stuff didn't line up 100% very well, and clearly the machining wasn't done extraordinarily well, but it does work, and it was able to get together. Talking about the servos, so this is the x-axis servo, and the a-axis is mentioned as over there. These servos are not ridiculously powerful. They work and they move, but they can't really drive the machine that fast. The machine has a maximum speed of 200 inches per minute, which in the land of wood is extraordinarily slow. So like a professional wood machine, like, one that's a couple $100,000 ish or 100,000 plus, you're usually machining wood somewhere in the realm of 800 inches per minute, 1,000 inches per minute, depending on whatever you're doing. And here we're machining at 200 inches per minute, but it's a $5,000 machine. So you get what you pay for, which is perfectly fine. Now, my gripe with these servos is that they really don't have a lot of acceleration in them. And I've had some issues cutting. It might be hard to see on screen, but it looks like sometimes when this cuts, it's having some issues with the radii and managing the acceleration with the radius. It's almost like it moves around, overshoots a little bit, and then comes back. And that might be fixable by changing some of the smoothing and acceleration settings, in Mach 3. And if you look at Mach 3, when I was running this, and this slot was commanded at 200 inches per minute, you would actually see the machine slow down its acceleration and then continue, and then it would speed up again, which is the correct thing for it to do. But it didn't seem like it slowed down enough to actually manage that properly. So if I think I can probably change some settings in Mach 3 in order to change that. But honestly, for cutting MDF like this, 200 inches per minute is kind of too much. And I've also learned that when you push this machine a little too much, you start losing counts on the servos or on the stepper motors here. And when that happens, your stuff's not accurate anymore. So, so I would just watch out for that. Make sure you're not pushing the machine too hard, because you'll exceed the limits of what it can do. So for stuff like this, I've started doing this at like 100 inches per minute. And then when I go around corners like that, I try to slow it down to somewhere in the realm of like 50. And then I actually start slowing down like about a quarter inch or so before the actual radius, and that seemed to help a lot. So clearly there's just some acceleration issues which need to be managed. Also, when I opened the Mach 3 configuration, I was looking at some of the accelerations. I noticed that this guy, the x-axis and the a-axis were set differently. They had different acceleration values, even though they're the same servo. So I changed them to be the same. I'm sure that was just, they forgot to configure that. Servos, I believe, are all identical. They're just placed differently. If I were to change one thing on this machine, I would probably upgrade the servos just so it can move a little bit more. There's a lot of really great servo packages out there, like ClearPath. ClearPath does some stuff. And I think what I would try to do is I would try to change it to like a closed loop system where it's actually keeping track of all the counts and things like that. So you're not magically losing any counts or anything everywhere. Just because it's hard to tell when it's going to lose counts and when it's not. So you kind of have to run at sort of a more conservative level than you maybe would want to. So I would just watch out for that. Spindle options, you can order this with different spindle options. I called up Zenbot and I talked to them about spindle options, and they recommended the Hitachi MV12 or 12MV, MV12, and it's a decent little router for what it is. But the thing you got to remember is that is a hand router. That is a router that you would buy at a hardware store and then use it to cut molding or something like that for your house. So spindle-wise, that's the level of performance that you're looking at. And this machine can drive probably, I would say, an extra 25 to 50% beyond what really the spindle should be doing. It's my plan eventually to get like a 3-phase air-cooled spindle, and play around with VFDs. I've done some VFD stuff before, so like I know how to set all that stuff up. So, I'd get like a 2.2 kilowatt, air-cooled 3-phase spindle or something like that, maybe 18,000 RPM or something like that. And that would be, I feel like a much better fit for at least what I'm doing, because I want a little bit more juice out of my spindle, just so I can keep cutting my MDF and not bog it down or anything like that. Another thing I want to try doing as an improvement is you can get these little touch-off blocks from Amazon. This one was a whopping $7. And all these is just a circuit. And this is just a metal plate. And then you attach this clip to the tool. And then when the tool touches this, it completes a circuit. And so you can tie that into the electrical system. And then in Mach 3, you can use that to have the machine touch off the tools. So that would be something I would like to add to my machine, just to make tool changes and stuff faster. I've ordered some new collets, like it's called the muscle collet, I believe. Muscle collet. which should be a little bit better for the spindle and whatnot. Just because I want to get cutting now rather than worry about doing the 3-phase spindle stuff just yet. This machine is also all belt driven, so these are the belts. So you have to do belt tensioning and stuff like that. There's the Z-axis belt, and then here's the Y-axis belt. And the belt tension does significantly affect performance. So I tightened everything once for the first time, and then I did some cutting. The belts loosened up because they were breaking in, and then I had to re-tighten everything. And then when I went to go cut again, the positioning of everything was off, which is to be expected. But just be aware that when you're using a belted machine like this, the belts are going to break in a little bit. Once they break in, you're going to have to retension everything, which is, I don't know, it's not a big deal. It's a 10-minute job, 20-minute job, but it will change where everything is. So make sure you re-zero stuff. See. Yeah, electrically, I think it's pretty good. Like I said, it's only running on 115 volt circuit for the axes, then another 115 volt circuit for that. It's my plan to set up like a dust evacuation system, have like a biscuit that goes around here with like a vacuum over here. You've seen them. They're just like little bristles. Sometimes they're referred to as shoes, like dust collection shoes. So I'm going to probably end up building one for this just because I'm not... there's not like a default one you can buy, but it wouldn't be very hard just to bolt something in down there or bolt something around here or something like that. That's just a shoe that goes around that. And that's something that you could realistically build on a machine like this. So it's, it's no big deal. Just something you need to do. One of the other problems I had, and I would consider this fairly significant, was the actual table portion is made out of multiple spaces or multiple pieces underneath this. And there are significant alignment issues with these table pieces on the machine. So, it's pretty good up till about here, but you'll notice that as we get sort of over here, these holes don't really line up anymore. And I don't know if that's an issue with the actual plates. Yeah, here you can see the different plates. If that's an issue with like the plate machining, or if that's the holes were drilled in the wrong place on the plate, or the outline of the plate is wrong. I'm not 100% sure on that, but it took a lot of force from two people, one of them being me, in order to get these all in here. And I would consider that kind of an issue. So stuff doesn't necessarily always line up right, but it's a $5,000 machine, and you're kind of getting what you pay for there. So, construction wise, it's built off of these big frame rails. I did buy the stand, although the stand parts aren't here, so I guess we'll just have to do that later. But these are big U-line square pieces of tubing, and then they have a threaded area here on the back side of the tubing, and then there's bolts that come through this plate and then pull this against the plate here. Kind of an interesting way to do it. Not necessarily the most stable, but for the price point, this is probably how you would have to build the machine. You wouldn't be able to have like some sort of base and then something riding on top of the base. You'd sort of have to use the structure of the machine as the rails themselves. I'm pretty happy with the alignment of like the skew of the alignment. Like it seems like the machine's actually pretty straight for the most part. It's certainly adequate for wood applications. I would definitely question it for like metal applications. But for just building wood projects in a hobby plus type scenario, it's totally there. So yeah, so that's about where it's at. Oh, so you're probably wondering how long did it take to assemble? So if you had all the parts with you, you could assemble it probably in the order of 4 to 8 hours. And that's including troubleshooting and stuff like that. If you've done stuff like this before, obviously to be shorter. If you've never done it before, it might be a little bit longer. But I would budget a day or two just to get this machine together, get everything working, and make sure you get 32-bit Windows, and that'll get you where you need to go. So if you're looking for something in the $5,000 price range that will work, that's decent, for hobby plus type applications and work, I think it's a great machine. If you need more than that, if you need a professional grade machine, or you need hardcore industrial machine, you're definitely going to have to spend more than 5,000. You'd be in the 10 to 15 minimum. And obviously, if you have a formal wood shop, you're probably going to be looking at the machines that are $100,000 and above. So just be aware of what you actually need, and I think that'll be fine. You can call up the guys at Zenbot CNC. They're super nice. You can ask them whatever questions you need to ask them. And they're generally very helpful over there. So give them a call if you need anything or have any other, very specific questions. But otherwise, there you go. That's the review of the machine. And thanks for your time, and have a wonderful day. Bye.